Hi everyone, I'm going to give you a little lesson on functions to help you with your worksheet. Functions, remember, you can think of like a machine. Something goes in, something happens, and something comes out. What happens depends on how the function is defined. Here, the function is defined by multiplying by 5. So the 2 goes in, it gets multiplied by 5, comes out as 10. When you input -4, it gets multiplied by 5, comes out as -20, etc. How we'd write this in function notation is we write our function. When we input an x value, something happens. What happens? We multiply it by 5. So when I input 2, 2 is my input. It gets multiplied by 5, and it comes out as 10 as my output. Function notation just helps us categorize that in neater terms. What happens in the middle is usually called the function operation. The function operation is what turns my input here, which was 2, into my output, which was 10. So let's do an example without any kind of math first, just the mapping. If I look at this example and it says find the value of my function when I input a 4. Here, my inputs are represented by x, and my outputs are represented by my function acting on x. So I find 4 in my list, and I see where it's being mapped to. It's being mapped to -3. So my output here is -3. If we were drawing this in coordinates, it would correspond to my x coordinate of 4 and my y coordinate of -3. Here, it's a little stranger. 3 times f of 2 subtract 5. I need to know what f of 2 is in order to evaluate this. So that means my input is 2. I find 2 in my list, and I see where does it go? It goes to 6. So f of 2 gets mapped to 6. Then I can evaluate this by replacing f of 2 with its value, which is 6. So I replace f of 2 with 6, subtract 5, gives me 18, subtract 5, gives me 13. For C, if I want a value of a such that f of a equals 7, then I know 7 is my output, and I have to work backwards to find what value I put in there. So I find the 7, and I trace it back, and I see what did I put in there to get to the 7, and it must have been a 3. So I would say f of 3 equals 7, therefore a equals 3. Next, we're going to look at a graph. So a graph lists the relation between your x coordinates, which are your inputs, and your y coordinates, which are really your outputs. And it lists all this information in terms of lines and coordinates. So a coordinate, like this one here, is easy to read off. That's the coordinate 2, 3. Lines, remember, are also coordinates. They're just so close together we can't see them. But a line is just a series of continuous coordinates here. So what we really have is a bunch of coordinates that specify the relation between x and y here. So if I want to start here, I want the value of my function when I input -3. -3 is my input, so it means my x value here is -3. So what I do is I go over to my x-axis, I find x equals -3, which is here, and then I trace it to my graph, and I see what's my y value when I intersect the graph here. So it's almost like I draw a little imaginary line going through x equals -3, and I find my point of intersection here, which is this coordinate, which would be the coordinate -3, -4. So my output when I input a -3 would be -4. You can think of this, f of -3 really means my y coordinate when my x equals -3. So really this means this is an x and an f of x coordinate. F of x is really acting just like y always did for us, just a change of notation. Next, I'm going to input a value of -1 into my function. Remember, this means my x values are -1. I want to see where did it get plotted. What's the corresponding y value? I go over to my graph. I find an x value of -1, which would be here. I trace it down to my graph, and I see I intersect it right here. Where is right there? That's the coordinate -1, -2. So my corresponding y value to x equals -1 is -2. And that is what I define to be the output of my function here. C, f of 2, same idea. I find my x input of 2, which is here, and I go up. This is a special kind of function that you don't really have to worry about right now. It's a piecewise function. The hollow dots means the function isn't plotted there, it's plotted where the gray one is. So I go here, and this is my coordinate 2, 3. Therefore, f of 2 is plotted to 3. And remember, all of these can easily be read as coordinates off my graph. This one's 2, 3. This one is -1, -2. And they all correspond to an x and an f of x coordinate. For D, it says find A such that f of A equals -2. So it's kind of the working backwards approach where they told me what my output was. So I find -2 on my graph here, and I cross it back. So find y equals -2, then to go over to my graph and see what's my corresponding x input here, and it was -1. So I would say A equals -1 here because f of -1 equals -2. And that's all shown in this coordinate here, which displays the relation. So remember, coordinates, graphs, tables are all ways to represent functions. They all convey the same information, just in different looking ways. The last one I want to look at is an algebraic approach. So this means I'm given the function operation here. So my function operation, which allows me to find any input or any output given an input like 31 here. It's saying find the value when x equals 31. So what I do is I plug 31 into my function. That means wherever I see an x, I'm going to replace it with 31. I simplify that to 36, take the square root, and that gives 6. So that would correspond to the coordinate of 31 and 6. And I'd say as my final answer, f of 31 is equal to 6. That's the easy way when you're approaching algebraic approaches. The second one is a little harder, where they say, all right, the output of my function is going to be 10. What is x? So what did I plug in there to get my output? Well, what I have to do is go back to my function formula and replace 10 with f of x and solve for x. So I have to solve this for x to get rid of the square root sign. I'd square root both sides, which would give me 100 over here. And squaring the square root sign cancels it out. I'll have x plus 5. I have one operation left. Subtract 5, and I would get 95 is equal to x. So when I plug 95 into my equation, I should get 10 as an output. And I could verify just to make sure I'm right. Remember, my function is defined by this. If I plug x equals 95 in here, then I get the square root of 95 plus 5, which equals the square root of 100, which equals 10, as I thought. So, Where was all that? The function as a machine, inputs and outputs. We have mapping functions. We have graphing functions. We have coordinates, list of ordered pairs. We have algebraic ways of defining functions. These are all the basis of input to output. Now the ones you'll be doing today are mostly graphing ones, and they're a little easier. Just one extra thing I want you to look at. When you have a function like this, x squared plus 1, and you're trying to solve, say, if I told you the output of my function was 26, what was x? What you have to do is put 26 in place of f of x and solve for x, which means we want x alone on one side, so get rid of that constant. And you have 25 is equal to x squared, and then you have to undo the square by square rooting both sides, and you get plus or minus 5 to be x here. So don't forget about the algebra steps of solving to isolate x on one side of the equation. Okay, I hope that helped. Good luck with the worksheet. The answers will be on Google Classroom, and don't be afraid to rewatch this video as you go through it. We'll see you tomorrow.